with more and more being discovered each year. Of these exoplanets, roughly 10% have been confirmed as being super Earth size, and that's not even the craziest part. There are an estimated 155 billion super Earths in our Milky Way galaxy alone, making it the most abundant type of exoplanet. In order to understand the formation of life on our planet and the possibility that it could evolve on other worlds, we have to look outside our solar system. But if there are so many super Earths, what makes these ones so impressive? It's all about scale. Cosmic bodies are so far away, the distance and numbers become so large they start to lose all meaning once we start talking about 10 to the nth power. To get an idea of just how large the universe is, it helps to put it into a scale we can understand. Imagine the Earth as a single grain of sand, with the Moon a speck of dust orbiting from 1.5 centimeters away. Comparatively, the Sun would be around the same size as a pool ball 6 meters away from the Earth. Keep in mind the largest known star, Canis Majoris, would be 39 meters in diameter, 684 times the size of our own Sun. The solar system is 4 football fields wide, with our little pool ball Sun at its center. The star nearest to us, Proxima Centauri, is now 1,572 kilometers away. Take another step back. The Milky Way galaxy is 46,375,000 kilometers wide compared to the tiny grain of sand that is the Earth. Now, imagine that our solar system is the grain of sand. It sits in the Milky Way galaxy, which is 50 kilometers wide, and our nearest neighbor, the Andromeda galaxy, is 1,012 kilometers away. The observable universe sits in a field of view that is 37.2 million kilometers in diameter. Finally, shrink the Milky Way galaxy down to that grain of sand. The entire universe is as big as the Empire State Building. Light leaving our galaxy travels 1 centimeter away to the Andromeda galaxy, taking 2.5 million years to complete its journey. The universe is almost too big to comprehend, which begs the question, how many Earth-like planets really exist? The Drake equation. Dr. Frank Drake put forward a simple equation in 1961 to not only quantify the potential number of civilizations in the universe, but also to stimulate scientific minds to start prioritizing the answer to the big question, are we alone in the universe? The equation is formed by simple variables that add up to give you the number of civilizations in the Milky Way galaxy who are advanced enough to produce detectable electromagnetic signals. It's the average rate of star formation in our galaxy times the fraction of those stars that have planets times the average number of planets that can potentially support life per star that has planets, times the fraction of planets able to support life and actually do at some point, times the fraction of planets with life that go on to develop intelligent life, times the fraction of civilizations that develop the technology required to transmit detectable signs of their existence into space, times the length of time the civilizations exist and release their signals into space. There's no real way to determine any specific numbers for any of the terms in the Drake equation. However, the concept was so profound that it prompted the formation of the Search for Extraterrestrial Life Institute, or SETI. SETI are the ones keeping an ear out should anyone be making a long-range phone call from way outside our solar system. Goldilocks planet. The habitable zone describes the range of distance a planet can be from its orbited star while still being able to maintain liquid water. We only know of carbon-based life, and it's clear that other carbon-based life would need water to form and survive. These planets are also known as Goldilocks planets, as they're not too close to their sun to cause water to evaporate, nor are they too far away that all the water turns to ice. There are more than a few exoplanets that sit in an orbit that could potentially support life. Howdy, neighbor! One of our nearby stars is a multi-planet system similar to ours and boasts at least 2 and as many as 3 super Earth-sized exoplanets. Now that we've explored scale, it's actually 11 light-years or 64 trillion miles away, so close in the grand scheme of cosmic things. This is important, as these 3 exoplanets around the GJ887 star provide one of the best possibilities for study in the search for life outside our solar system. GJ887 is classed as a red dwarf, which tend to be larger and more reactive than yellow dwarfs like our Sun. However, this red dwarf is relatively quiet and tame compared to others of its class. It produces less solar flares, so that the light, heat, and radiation it emits are more constant than erratic. The two confirmed super-Earths may be a little too close, and as such too hot to contain liquid water. However, the third is within the narrow band of distance dubbed the habitable zone. A close cousin. The exoplanet GJ357d is around twice the size of Earth, but also has 6 times its mass. It too falls in the habitable zone and likely has a dense atmosphere that could be able to trap enough heat close to the planet to allow liquid water to form on its surface. It orbits a star that is a third of the size of our own and around 40% closer. A year is 55.7 days, and the distance is around a fifth of the Earth from our Sun, meaning it's very likely to have Earth-like conditions. The best super-Earth contender. Over towards the center of the Milky Way galaxy, 1,200 light-years from Earth, in the constellation Lyra sits Kepler-62f. It's a curious exoplanet that is being dubbed a 1 in a million super-Earth. Its mass is 1.4 times more than that of Earth, small enough to have a rocky composition with a molten core. Its brown dwarf star is much smaller and cooler than our Sun, and although the exoplanet is in an orbit the distance of Venus from their Sun, the distance relative to the heat of their Sun is similar to Earth. A year lasts around 267 days, and temperature conditions could be remarkably like that of our climate. So far, it is without a doubt the closest exoplanet to Earth that we've found by a huge margin. Its nearest neighbor, Kepler-62e, is another Goldilocks planet 1.6 times the size of Earth that also sits well within the habitable zone of that system. Modeling the two planets based on the data recorded points to both being engulfed in water, having great seas and oceans just like our own. Atmospheric gas could lead to trapping the water vapor, forming clouds, and causing precipitation. With life evolving from water, they are great candidates for the best chance of finding life outside our solar system, if we could only get there. The gravity is less than Earth's, and human beings would have no trouble walking around on its surface. Though the atmospheric composition of Kepler-62e could potentially support respiration, Kepler-62f is totally out of the question. Spacesuits with breathing apparatuses would definitely be needed. Life on these worlds would have to be totally aquatic, which begs the question, would an intelligent civilization on these planets be anything like ours? With no exposed land, there would be no dry vegetation, which means no fires to cook food with, to melt metals, or to generate warmth. As the planet's surface is well below sea level, harvesting resources and mining materials from the solid ground would be very difficult. On Kepler-62f, if the planet's rotation is not locked with